Hello, everyone. Please let me know if you can hear me well. For example, write something in chat, please. Okay, great. So yeah, let's give folks a couple of minutes to join in, and then we'll start. Okay, I guess we have a quorum. So just a couple of words regarding the format. Today we are going to have our Airflow workshop. And during the presentation, you can use this Zoom Q&A functionality or chat in order to post your questions. So we will answer all the questions during the workshop. And yeah, I guess we are good to go. So let me start with our agenda. First of all, we are going to have a really quick intro regarding Apache Airflow. And after that, we'll have two separate practice sections. So just a reminder, we have Python and Docker as a prerequisites for the practical sections. So I guess Andrei or Sivak will post the link to the GitHub repo so you can set up your environment now. Okay, then speaking about our team, today we have Andrei Listratov, our data engineer, also Sivak Avitisyan, our senior data engineer with us as well, and me as a delivery manager on one of our projects. Okay, and then I'd like to take next couple of minutes and give you a really quick overview about the Grid Dynamics company. So we are a public company with our clients from Fortune 500 lists. And basically, our main focus is digital transformation for various business domains. And speaking about big data community, we have around 200 big data engineers distributed across 5 different countries. Also, we have 40 plus ongoing big data projects. And I would say that we have a pretty major big data community with a lot of experienced and really motivated engineers. And speaking about the projects, it might be some common ETL processing projects or cloud migrations or integration of data governance approaches, or even close collaboration with data scientists on machine learning projects. And to be honest, in almost all of the projects when we need orchestration tool, we are using Apache Airflow. And I'll describe you why. So let's start with orchestration is general. So orchestration is a way of connecting several applications components in order to provide appropriate interaction between them. So for example, we can just imagine the image processing pipeline, which, for example, at first stage resizes some image. After that, it is going to apply filters and as a final step, just export output into some downstream process. Or another example, let's say we have a sequence of tag jobs which connected with each other by inputs and outputs. So in some non-trivial way, let's say, and it means that we definitely need some orchestration solution in order to manage that. And as you may know, there are a lot of actual products on the market, and we'll focus on Airflow today. So Apache Airflow is a scheduler platform which allows you to define your workflows and pipelines using Python code as a DSL. And let me then throw a couple of definitions from Airflow. So let's say we have a general business tasks which might be solved with directed acyclic graph or the pipeline in Airflow terminology. So we can split our business task into different components which are named as tasks in Airflow. And basically we can split all the tasks into two major buckets, which are operators and sensors. The operators are basically responsible for execution of some actions, and sensors are waiting for some external events, for example. And one more thing regarding features. So initially, Airflow was designed as a batch-oriented solution. So it means that if you have some real-time processing, then it's not a good idea to use Airflow for that. But anyway, with Python code, it provides really good flexibility and a lot of features out of the box. And of course, we will cover major of them during our today's workshop. And here on the right side of the slide, you can see an example of a particular pipeline in Airflow Web UI. So here is a deck with multiple tasks which are connected with each other. And let me also show a couple of screenshots from the UI. So here we can see a list of our decks, our pipelines with corresponding schedule intervals and statuses. Also, here is a pretty useful tree view, which allows you to track the progress of execution, track the execution history with all the statuses of particular diagrams and particular tasks inside the pipeline. And also for particular task here, you can also override its status or, for example, just look into the logs. Okay, then let's go and write our first minimal Airflow pipeline. So we need around 20 lines of code for that. So here we have a deck with particular name. description. We are setting schedule interval as a cron expression, so our DAG is going to be triggered each 5 minutes. And here we can see two separate tasks, two separate operators. First one is a bash operator, which executes date command. And the second one is a Python operator, which executes this print hello function. And here's also an example of web UI for this simple DAG. And yeah, a couple of more screenshots. So here we can see we have two successful executions. The last one is still in progress, and we can also see the logs for our print hello task. Okay, then let me just briefly describe general concepts. So as I mentioned before, there are a lot of operators which also maintained by the community. And also with operators, you can not just define what to do, but also you can define structure of your DAG. I mean, you can use branching logic or even trigger one pipeline from another. And also, if you need some prioritization on tasks, on pipelines, you can use mechanism of pulls and queues. And also for some external integrations with, let's say, databases, you can use hooks, connections for that. Also, you can store configuration variables. And yeah, we will cover all those parts later today during the workshop. Okay, and one more point regarding the life cycle of the task. So initially, it just spawns without any status. After that, scheduler selects a particular task for execution. Then executor component is going to move this task into particular queue. Then worker extracts task from the queue, actually executes it, and as a result, it might have different statuses, for example, success or failed. And yeah, that's basically it. Also, there is one more status, especially for sensors, and yeah, we will cover that later. Okay, then regarding infrastructure, let me show you an example of Airflow setup with Cellular executors. So here, as you can see, we have one master node with Airflow scheduler and web server processes. And also there are several worker nodes. Also, we have a message broker, which is responsible for communication between separate nodes. And there is a database as well for storage of meta information. And one more thing regarding the environment. So since we are living in Python world, we are using Python virtual environments for all the management of dependencies. So it means that each process on master and worker nodes should have its own environment. But if you need more flexibility and customization, you can even define your own virtual environment inside the particular task with Python virtual env operator. And the last point regarding migrations. So if you're going to have this Airflow setup in production, you should keep in mind that there are different versions of Airflow, of Python itself. So you should allocate some capacity, not only from the developers for such migrations and code adjustments, but also on the infrastructure side as well. And yeah, one more point regarding the integrations. So Airflow have several types of executors. Some of them are more suitable for local testing and debugging, but with other, you can build a pretty good production-ready system with all the scaling features, fault tolerance, and stuff like that. And also like to mention that in terms of cloud integrations, it supports major cloud providers, such as Azure, AWS, and GCP with custom operators, hooks for that. And as for the interfaces, we have Web UI, and also there is a command line interface, REST API, and Airflow database. Okay, it's time to move into our practical section. So today we are going to launch a rocket. And in terms of implementation and details of our, let's say, business task, first of all, we should actually wait for the approvals from the command center, after that, we are checking weather conditions. And if the weather is fine, we can just go ahead and proceed with launching. Otherwise, we are going to toss a coin and check if we will postpone our launch for today or launch the rocket. So yeah, the next step is launching the rocket, and as a final stage, here we have this item which checks that everything is fine and all systems are working as expected. Okay, then regarding environment setup, as I mentioned before, we need Python and Docker. Also, here is a link to our GitHub repository. And yeah, I'm going just to set up this environment right now with you. So yeah, let me just open this repo and quickly show you these instructions. So here we're using Docker Compose in order to wire all the containers. So let me launch that. And meanwhile, while it is in progress, I'm going just to briefly show you the Docker Compose file. So here we have our Postgres database as a service for Airflow. Also, there is a Redis as a backend for Cellular for messaging, basically. Also, here is a command which responsible for initialization of Airflow database. Also, there is a web server, Airflow scheduler, and Airflow worker. And I believe that's it. And let me jump into this DAGs folder and show you our minimum example of the DAG. So here is the DAG name. We are going to run it once every 10 minutes. And it has only one task, which basically executes this bash command. Okay, then let me go to Web UI and check. Yeah, so it is up and running. Let me enable our pipeline, then refresh the page. And yeah, as we can see, here is the DAG run, which is in progress. I can refresh that, and yeah, the task is completed. This one, we can go here and check the logs. So yeah, here is output. What else? Also, we can trigger our deck manually. Let's try. And here in preview, there is a history of runs. And yeah, so it already completed. Okay, so it means that we have all the initial setup and ready to go. But let me just quickly show one more thing. Yeah. So here is a page with the resources. It contains link to GitHub repo. And also here is a link to official wiki page with common Airflow pitfalls. And there is also official Slack workspace. And here is a QR code to Airflow Russian Telegram community. So there are already more than 1,000 of members. So feel free to join. Let's share our experience and knowledge. Okay, so that's basically it, what I have for this section. If you guys have any questions, comments, feel free to post them into chat or Q&A section. And then I would suggest to have a really quick 5 minutes break so you can set up your environment, check out this repo, and yeah, if there are any questions, post them into the chat. And right after that, we will proceed with the practical section from Sivak. Let me just start the timer and mute myself. Okay, Sivak, I guess we can proceed. The stage is yours. Please go ahead.
Okay, guys, can you hear me?
Yeah.
Can you hear me? Can you see me? Okay, let me share my screen. Okay, I have to log in to share my screen. I'll have to quit. I'll join in a second.
Okay, sure.
Let me. Now it should work. I guess. Yeah. You guys, can you see my screen? Just post something in the comments.
Yeah, we can see it.
Okay, so start with some simple stuff like, okay, now we have this simple DAG, which, as we've seen, as Paul has already shown, that it just execute this bash command and print something to logs. That's it. So how does Airflow know which files contain DAGs and which files needs to be parsed? So basically, how do I get list of DAGs here? Scheduler is responsible for the process, and what it does, it looks for all the files in the DAGs folder, which is, let me show you that we have DAGs folder in web server, which is by default of Airflow DAGs, and we have that folder mounted to DAGs folder here. So whatever file I put here, Airflow scheduler will try to parse it. And to be more specific, we can take a look at the internals, because that's very not tricky, but that's interesting how Airflow does that. I'll just show you a couple of functions. There's a function that is responsible for loading DAGs from file, and it calls another function that is called might contain DAG. So if we look at that function, what it does, it literally reads the whole file and then checks that it has words DAG and Airflow. And what that means is, if I go and create any Python script, add any other, and add those two words to the file, that practically means I can have literally any valid Python code here, and scheduler will try to parse it and that means it will execute this file. But this is not the DAG. And yeah, that's one thing that I wanted to mention. So, okay, now we have the simple DAG, and we know how Airflow loads DAGs. Let's see. Let's look at the parameters that we pass to DAG. Well, already covered them, but let's just take a deeper look at them. So the required ones are the following. That's DAG ID, which is shown here on the web UI, and it should be unique. And it's literally any valid string. Then we have schedule interval, which can be either cron expression or there's a short hands for the schedule interval like daily, for example, and then they can be looked up in the documentation, or I guess somewhere somewhere here, but I don't want to spend much time on that. Yeah, and then we'll have we'll cover catch-up in a bit. So let's suppose, and again, this is a bit not what you would expect from Airflow when we specify start date as some date in the past. The first question that you might have is, yeah, I have start date at April 1st, 2021, and my DAG is going to run daily. So the first question is, when the first DAG run is going to happen? And what you might think, it would it will be run at April 1st, 0.00. So, but that's not actually true, because the first DAG run will be not at midnight, but at start date plus schedule interval. So practically that will happen only on April 2nd. And that's probably coming from the fact that Airflow was designed for batch processing, and let's imagine that we have some ETL pipeline, and we know that we have some historical data coming from April 1st till today, and today is April 22nd. And I will have the only at the end of the day. That's why I should run my pipeline only at the end of the day. So meaning that the first DAG run will be at start date plus schedule interval. Okay. But this schedule interval also can be set to none, which means that this DAG has no schedule and it will be triggered only manually. So you'll literally have to go to UI and go to UI and then trigger a DAG. And as you can see, the schedule has changed to none. Okay. Now let's create a couple of tasks. And again, as well mentioned, task is just a piece of work that we want to run. And a couple of important things about tasks. We want them to be reproducible. So in case one of the tasks fails, we continue running our pipeline from that point, not from the very beginning. Okay, So let's say that we'll just rename this hello task and say this is prepare for the launch. Let's say prepare for the launch, and we'll echo something like link. Now we're preparing for the launch, and we can again go back to the DAG. And here we have tree view and graph view. Let's look at the graph view. And as we can see, the what we see in the web UI seems outdated. And that's because the scheduler parses docs by default. I believe that's every second, every minute, not every second. That's why you literally have to wait, or you can just click on this refresh button, and it will cause scheduler to parse that. So now we'll see that it has changed, and I can even go to the code tab here and make sure that, yeah, this is what I expect to have in this DAG. And now execute it. Let's just trigger it. Go to graph view. And yeah, now we can go to the logs and check logs of the specific task. I was in it printed what I wanted. And yeah, now the DAG is in success state. Okay, after that, what we want to add, let's say we want to add like launch the rocket. We'll say launching the rocket. Okay, but if I leave it as is, go to the UI, I will see that I have two tasks, and even if I trigger the DAG again, make sure that, for example, prepare for the launch will run before launch the rocket task. In this case, they will run in parallel, and I cannot make sure that they have some specific order. So how do I specify the order or the dependencies between tasks? There are a couple of ways. Let's say if I want to say that prepare for the launch goes first, I can set, call literally set downstream, and pass list of tasks that needs to be run after this task. So that can be literally single task or a list of tasks, and we'll cover that later. But there's a shorter syntax for this. And we can say prepare for the launch, the shift, launch the rocket. And under the hood, actually, what happens, it just calls set downstream. I go here, it's nothing fancy. Yeah, and now I can command this, go back to the web UI, and see that, yeah, actually, this guy should run first, and this should run second. Okay. And in opposite to set downstream, we have set upstream. So if I say prepare for the launch, set downstream, launch the rocket, this is the same as launch the rocket, set up for the launch. And again, I could have written this way. Okay, let me comment this. Now let's just execute the DAG one more time. And look at the state of the task. So firstly, task is queued in the queued state. What happens next? Because this task ran so fast, I could not show you that, but what I can do, I can actually put some sleep here. Say, let's sleep for 10 seconds. And let's actually make sure that that has been parsed. Yes. If I execute this one more time, we will see that firstly it was queued, then scheduled, then it's in the running state, and from the running state we can go to either success or fail, or up for a try or up for a schedule. We'll cover this one later, or skip. And as far as there's no errors in my code, it worked fine, and we've ended up in success state, and the DAG itself should be success. Yes. Okay, and now what we can also look at here, we can see that we have a bunch of DAG runs. So the DAG run is when actually the DAG was run. So let's say that we have the concept of DAG, which is something abstract, just a bunch of tasks that needs to be run. But if we want to say, okay, this DAG was run at midnight today, that concept is DAG run. And I can see that DAG runs can be either, they have run ID, and the prefix of run ID can be either scheduled or manual, depending on whether that was scheduled run or manual run. Okay, and I can actually see the start date and end date and the state. Okay. Now let's look at the following scenario where we want to have some branching logic based on some logics, take decisions and run either this task or that task. What we can do is there's a branch operator in the Python in the Airflow. Let's go back here. Let's say we'll have toss a coin, and this will be branch Python operator. Let me check that. And again, as any operator, it will have task ID. We'll say this is task coin. And now it accepts Python callable. So this is a function that will encapsulate the logic of this tossing a coin. Let's say toss a coin function. And let's define that function first. The idea is following. This function should return the ID of task ID of the task that should be run. So in this case, what we want to do, we want to toss a coin, and in case in case it heads, we want to prepare for the launch. Otherwise, we want to say we are not going to launch today. Let's add one more task saying no launch. And we'll say go home. No launch. So simply saying what this function will do, it will literally take, let's say, randomly one of the task IDs that I provide here, and that would be either prepare, either launch the rocket, right? Or no launch. Okay. So now if I go back to the app UI, and actually I should say that this does a coin and goes first. Yeah, and I should say that, what do I say here? I say toss a coin should be either it's connected with prepare for the launch or no launch, right? And in case we prepare for the launch, I'm gonna launch the rocket. Now this is how I specify multiple branches, or actually multiple downstream dependencies of this task. I go back here and click refresh. This is what I want to see. So we'll toss a coin. If it heads, we'll prepare for the launch and then launch the rocket. Otherwise, we'll say no launch. Now let's try to run this a couple of times. Okay, and we see that if we have, let's say, two branches and only one is chosen, others will be skipped. So all downstream dependencies of this no launch will be skipped. And as far as I don't have any, I see only no launch in skip. And yeah, we've successfully launched the rocket. Let's try to run it one more time. Then more successful this time, and we'll have no launch. Yeah. In this case, we see that all downstream tasks, all downstream dependencies for prepare for the launch are skipped recursively. And we'll see that we have no launch today. View logs, go home. Okay. Okay, what's next? Now let's say that, as well mentioned, there are two kinds of operators. One, tasks actually. One are operators and the others are sensors. And let's say that we want to wait for some approval and only then execute this logic. So let's say we want to wait for some file in the file system, and when the given path exists, that means that we've gotten approval and we should proceed with procedure. And for that, we have, as you might think, file sensor, and I will show you how to write it and what needs to be configured in addition to just writing the code. Let's say that we have, I will say wait for approval. File sensor. Yeah, it has two parameters, task ID and we can look it up. File sensor as file path. And the file path would be like opt airflow. And if you remember, we've had a bunch of folders mounted here as volumes. We'll have folder called files, which will be mounted to opt airflow files. Let's just copy this. And let's say approved. We would be expecting for file with name approved here. And as we can see, as far as I deleted the file, what's going to happen? And let's say that this goes before task appoint task. Yeah, so generally how sensors work, not only file sensor. There's a function called poke, and then there is poke interval. So what's going to happen is Airflow is going to call this poke function and check whether some condition is true. In this case, whether the file exists. And it's going to do that every poke interval seconds. So by default, if I remember this correctly, if we go to the base class and look for the poke interval, it's 60 seconds. So every minute, Airflow will run this poke function. We also have timeouts modes, and let's also cover modes. So mode can be, let's see here. Okay. We have either poke or schedule. So what is the difference between those two? Let's just cover another concept of slots. So whenever task is running, it occupies a slot in the queue. And by default, each task is running in the, if we go to admin pools, and a default pool, which has 128 slots. And yeah, and if I go and execute this DAG, what's going to happen? As far as file sensor is running, I don't know, every second by default, it will occupy the slot. And what can happen if we have lots of sensors, whether that file sensor or S3 key sensor, whatever, it will keep the slot occupied, and that will prevent other tasks from running because there are slots in this pool. What we can do, how we can improve, and that's the default behavior in case of mode equal to poke. If the mode is equal to reschedule, what will happen actually is Airflow will run the poke function, and if the condition is not met, it will release the slot and try it after the bulk interval. And going even further, in Airflow 2.0, we have smart sensor. And under the hood, it batches all bulk executions of all sensors running in the Airflow, which can significantly increase the performance in case you have lots of sensors. Okay, now let's go back to the web UI. Don't have DAGs yet. That's because I forgot to specify DAG, and in a minute I'll show you how to get rid of this and not specify DAG for each task. Okay. Yeah, now we have this wait for approval, and let's actually set the bulk interval to 1, so we can see that it's running every second. Let's go and run it. View. Now, if we go to the logs, we would see that it's looking for file, Airflow files approved. And as far as it's not there, it's still bulking. And I can go to pools and see there's one slot occupied, and it's occupied by this task, wait for approval. Yeah, so let's go back here and create that file, approved, and see what happens. Yeah. Let's go to view logs, and we see that success criteria meet. We're exiting and continuing our flow. Yeah. Unfortunately, no lunch today. Okay. One thing that I probably forgot to mention, because I had already connection set up, in order this example to work, we needed to create the connection, and we can think of this as connection to external source, whether this is file system or database or whatever. And internally, sensors and operators use hooks which use connections. And in order for file sensor to work, there should be, let me delete this and create it one more time. Connection with name F as default, and connection type should be file path, and this should be enough. We fill in any of these parameters. So we actually can look on the other connection types, like we have AWS, we have, I don't know, MySQL, HDFS, etc. Okay. Now let's see. We'll cover this. Let's cover one more use case. Let's say that we have some ETL pipeline which runs every day, and it actually uses results of previous day's calculations. So it cannot run, so we cannot have more than one active DAG run. So let's suppose that it's not daily, but I don't know, hourly, and the actual processing sometimes can take more than 1 hour of time. And by the time next DAG run should start, we're not done with the previous one yet. So we actually cannot start. And in that case, what we can do, we can specify maximum number of active DAG runs. And in order to do that, what we do, we can go to the DAG, and there is a parameter called active max active runs, and we set it to 1. And what's going to happen, I can show you that. Let me remove this approved here. Trigger this DAG more than once. As we can see here, it's in the running state, actually. Yeah. So the DAG itself is in running state, right? And I can try to trigger it one more time. And in the preview, we can see that we have 2 active DAG runs, but what's going to happen is it might have not applied yet. No. Okay, actually, let's try and see what happens. Let me add approved. Okay. What might have happened is this max active runs parameter was not applied by the time I have triggered the DAG. Let's try one more time, because this clearly did not work, and we had 2 parallel DAG runs, which is not what we wanted. Let's have 3. Actually, yeah, let's the file be there. That's interesting. Okay, I think I can further look at this. Maybe I have made some mistakes here. Well, yeah, okay, let's keep this. What else? Yeah, the parameter that I promised to cover and did not is ketchup. So what's going to happen when, coming back to this example, we have start date as April 1st. April 1st, DAG is running daily, right? And today is April 22nd. And today is the first time when I run the DAG. So what's going to happen? Airflow will try to fill in the gaps. Saying it will try to calculate all the scheduled dates starting from start date till today and see if there was no DAG run. It will schedule it. And in that case, we will have 22 parallel DAG runs. And in case we don't want to do that, we can set a parameter called ketchup equal to false, and it's true by default. We will set it to false. Okay, that's it from my side. Any questions? Well, I guess I can commit this to some branch, so guys can pull it out and continue, or just at least check if there's something to copy from here. What do you think?
Yeah, makes sense.
Okay, let me. I'm not sure that I have launch. Okay, well, you might have forgotten to give me permissions.
Wait a second. Well, as you can see, you already listed in collaborators.
Okay, I probably should have. Let me see. This might work. Yeah.
Oh, great.
Okay, I think we can. I'll stop sharing. We can make a coffee break for another 10 or 15 minutes and continue. Well, could you run the timer?
Yeah.
Okay.
Okay. Hey guys, hopefully you are still there. While we are waiting, I have actually good news. So we have this book, Designing Data-Intensive Applications, about the distributed computing, and one of you guys will get it for the most interesting questions. So I encourage you to be creative. And yeah, you'll get the prize. Okay. Yeah, I have just a quick note since we received a couple of questions related to infrastructure, setup, and all this, let's say, non-coding stuff. So with this direction of moving to clouds, actually GCP and AWS, they have their own managed versions of Airflow, let's say. So for GCP, it's called Composer. And actually you can, with a couple of clicks, just have a basic setup with all the functionality. Of course, you cannot customize it with all the available, ways. But for just basic setup, it should work. To be honest, I didn't use that on my project in production, but we played around it just for our POC project. And the similar thing, AWS also this spring released their managed version of Apache Airflow. So of course there are some overhead and costs for that, but you just don't have to manage any infrastructure. So that might also be helpful for some cases. Okay, and I guess we can proceed with the next practical part. Andrei, are you ready?
Yes. Can you hear me?
Yep, I can.
Great. So let me just share my screen. Okay. Can you see my screen?
Yep.
Great. Managed to copy all the work Sivak did, and I'm going to continue to build this DAG to launch the rocket. So first of all, let me mention the thing Sivak mentioned earlier with the how can you avoid putting the DAG everywhere. So basically, this is resolved with Python's context manager, and I'll show you how. So you can just write it like this as DAG, and put all of your operators right here in the context manager. Yep. And this stuff too. So at the moment we have the DAG everywhere, but let me just remove it and show you that it works in UI. So let me just, nope, refresh it. Yep, so here we can see that it works. And yeah, I have already created the file for approval, so it runs. Okay, so let's actually do something a little bit more interesting than a bunch of echo calls. Let's actually try to call the external API to get the weather. So we are going to use the the OpenWeatherMap API. And here's an example, which is exactly what we need. So we are going to retrieve the weather at the specified latitude and longitude, and with use of API key, which I created earlier, and put to the .env file. So how can we do this using Airflow? Well, there is an operator for that, which is called simple HTTP operator. Let me just do this right. Yep, here it is. So as we can see, it allows us to perform a call through HTTP and get the result. So what do we need for this weather API? Well, the method is going to be get, right? Yeah. So the method is going to be get. We also will need this relative path as a endpoint argument. So here's a docstring for this. We'll see that it is marked as templated. I'll explain a little bit later what that means and what's cool about that. So endpoint is this one, and we need to pass some data into it. So latitude, let's actually use something like 60, 30, which is, I believe, something near the St. Petersburg, but I'm not sure. It doesn't really matter. And we also need our API token to be passed here. So for this, we can actually use either we can store it either in the connection, but for this particular example, I will show how can you use it through the environment variables. So basically what you can do is just pull it here and key. And that's basically it. So let's name this operator. Let's give it a task ID. So get weather data. And let's see it in UI. So at the moment, it is not connected to anything. So here it is. We can see the actually rendered template, and well, I leaked my API key, but yeah, I will invalidate it. So this is one of the reasons you usually want to use connections for this kind of stuff, because in the render template you can see all the fields which are basically templated. And yeah, so let's actually try to run it. Another way of running tasks is to just click run. You can also, here you have ignore dependencies, ignore task states. Yeah, these are pretty much self-explanatory, but it is very useful when you're debugging some task and you want to run it again and again. Maybe you change something in HDFS and retry it manually in order to debug it. So yeah, just rerunning the single task is actually very useful. So let's see, and we failed. Let's see actually why did we fail. Oh, that's because we also need a connection for this. So one thing here, this as we pass this as a query parameter, it will appear in logs anyway, unless we like implement this the hook for that to not do it. But we won't do it right now. But we will create the simplest connection possible, which is basically similar to the FS default connection. But for this, we also need to set host field, something like this. All other fields we will leave empty. If we wanted to store some sensitive data, we would be storing it here, and the connection would automatically become encrypted. I'll show it later with the example of Telegram connection, but for this one, I would like to keep it that simple. So let me just restart my task. So this is what I'm talking about, basically. You can just force restart your tasks. And let's see. Yeah, so we succeeded. We got some data, but how can we access it now that we got some data? Well, there is a thing just for that in Airflow. There is a thing called XCOM. And the simplest way of using it is this. So what will happen as a result of this task, there is some data produced. And whatever is returned by this method here, this execute method, in this case, it is response text, whatever is returned, it will be pushed to XCOM. So what is XCOM actually is? Well, it is basically a table in the same Airflow database, and its purpose is to pass small amounts of data between tasks. So you don't have to write it somewhere or have some like external storage for that. You can just use the Airflow capabilities to pass the data around. And let's see what it looks like. So I'll use dbeaver. I've already created my connection to this DB, which is running as a part of Docker Compose. Let me just show you the connection properties. So yeah, in order to connect, you need to have some tool like dbeaver, and you set host to localhost, and database should be Airflow, and everything else should also be Airflow. It is as defined in .env file. So username is Airflow and password is Airflow. Yeah, and here you can see all the tables Airflow has. It actually stores pretty much anything in this DB, and in case sometimes it even might be useful to access it from here. So the very like bright example of it would be the case when you have started accidentally maybe, or you forgot to turn the catch-up of a DAG. If you accidentally started a lot of DAG runs and you want to kill them, basically what you what you can do. I'm not sure if it's like the only way for the modern versions of Airflow, but what you can do is you can go to this database, to this table, I mean, and you can just kill, just remove all the runs from it, which are not needed. So yeah, but we are looking at XCOM table. So what it is, basically it's a storage with all the with the value and all the identifying information you might find useful. For example, we know which DAG and which task at which execution date and with which key wrote this value. So later we can pull it in. Okay. So let us actually make some sense of this data. And for this, I'll need to create another task. So what we want to happen is after we get the weather data as a result of this operator, we want to run another task, which will perform some computations on this data and decide whether the weather is suitable for us. So let's create it. Is weather suitable? That would be a branch Python operator. And yeah, this would be a task ID. And let me just implement it. So there is a task, but how can we access anything from here? Well, there is a special thing called context in Airflow. And in order to interact with XCOM, task instances, or anything else, we need to provide it to the task, basically. So we'll include this flag. And what this function needs to accept is basically dictionary or a set of keyword arguments, rather. And let us just log it. Actually, it's pretty printed. So now we have this task, this task. Let's, for now, just connect this one to this one. Refresh. Okay. So we have this simple piece here. Let's try to run it. So as before, we succeeded in getting the weather data, but failed here. That's interesting. Oh yeah, because it's branch Python operator and I forgot to return anything, but it doesn't actually matter because we just did it at the moment, we just did it for this context thing. So context contains basically everything of interest in your diagram. It contains a reference to DAG, a reference to diagram, a reference to task and task instance, and yeah, so there are some even some shortcuts such as TI, which stands for task instance, and is basically the same thing as here. And there are also some timestamps and yeah, things like that. Okay. So how do we pull an XCOM here? Well, for this, we need a task instance. And let me just import it so we can have autocomplete. And this would be this argument or full name task instance. Let's just see what we get here. So among other methods, what is interesting here for us is XCOM pull. So basically, it's a method which allows us to pull XCOMs or get it by certain criteria. So in our case, what we want to do is we want to just say get weather data. And by saying this, it will pull the task IDs, this data from this task ID from the similar execution date as this operator, from the similar DAG, of course. But yeah, you can also like put, yeah, you can also return like data from previous dates and from different DAGs even. So let's see what is returned here. I'll just print it because it's a string. It is a string because the simple HTTP operator writes it like that. But actually, XCOM pool, I think, can store can store complex structures like dictionaries, and it will deserialize it for you. So yeah, if you have something like more complicated than a string, then this method has you covered. Let's rerun it. And it should fail again, but again, we are just looking at things. Oh, let's see. So this is the next attempt. And here we have this string, which is basically a response from OpenWeather API. Yeah. And what we need to do here is we need to actually deserialize it. It's JSON, so let me just. What did I import? Oh, I want the default one. Let's just deserialize it. And so what we are looking at here is the response like this, which basically contains some different the weather for some different time periods. And what we want to use is we want to use current. And let's see what does it contain. Let's even print it. So rerunning the task again. And yeah, so the third attempt. And what did we got here? Oh, yeah. So this is a context, which I'm actually tired of. And this is what we need, basically. So we won't be looking at any values here. For simplicity, we'll just look at the value here. So this is given as a percentage of something, I don't know, basically 0% is clear sky and 100% is like clouds. So let's just extract this. And we will no longer print it, but we'll make a decision based on it. So if it, let's say, more than, well, it was 75. So let's just do it like this. So if it's greater than 80, then we are not going to launch anything. And in other case, we are going to proceed with the launch. So, well, not proceed with the launch, but so the logic here would be, if it is too cloudy, then we will actually invoke this toss a coin task to let the chance decide. And in the other case, we'll just go straight here. Okay, and let's also properly connect it. So let's see. So I would do it like this. And here we would do this toss a coin or prepare for launch. And here we are also preparing for launch. Yeah, and after that we launch. Okay, let's see what we get. Let's see what we get. All right. So yeah, that's basically it. Let's try to run it. I will restart from this point because there is no point like in restarting this task because the result is already like in XCOM. But if you want to get like newer one, we could restart it. Okay, let's see. All right, so this task completed, but something strange happened. Actually, we got all the tasks skipped. So let me see. First of all, in this case, we want to check if we actually returning the right IDs here. So toss a coin, prepare for launch. Yeah, that's correct. Okay, but what happened here is that basically the result was to prepare for launch, right? Because we've got something like 75 there. And this task has returned the skipped status for this one and attempted to like start this one. So the scheduler does that. And what happens is, as this task is skipped, the skipped status propagates downstream, and so this task also gets marked as skipped before we launch it. So how can we avoid this? Well, in Airflow, it is avoidable by properly structuring a DAG, and by properly, I mean we'll need to add some nodes here, some extra nodes. So let's say yeah. No, actually, let's first cover the reason, the other reason it might happen. So vice versa, if this task is skipped, but we have managed to starting this task, then it will also get marked. It will also not launch because one of the upstream tasks was skipped. And this is basically happens because the default trigger rule is for this task is all the by trigger rule I mean basically start condition in Airflow is called trigger rule, and the condition would be that all the parent tasks are successful. This is the default, and we will also need to override this default in order for this to work. Okay, so let us do this. Let us first add some extra nodes in here, which will help us to manage this DAG. Let's say that we want to explicitly think of it as explicitly saying that the weather is suitable. We won't be using we'll be using dummy operator for that. Dummy operator does nothing. And this is exactly what we need, because we just need a way to provide an extra node in the graph. So, and here we'll say the weather is suitable. And we will connect it here. And in case the weather is suitable, we want to prepare for launch. And yeah, let me do it like this. In case the weather is suitable, we want to prepare for launch. Let's see what we get with this extra node here. Okay, so basically now in order for this task to launch, all of these should be marked as success, which is not really what we want. So let us add another such dummy operator after the second branch operator. So it is usually the case that we need extra nodes in the graph after the branch operators, actually. So let's do it like this. Let's say we are feeling lucky, and we'll do the same thing here. Okay. And we also need to connect it. So if we are feeling lucky, we want to prepare for launch. This actually can be rewritten like this. And if it was a coin, the downstream would be that we either are feeling lucky or there will be no launch. Okay, so what did we get here? Okay, so now it's starting to get more like more pretty. So let's actually just try to run it. So now we've got these two nodes which are upstream for this node, and now we see the similar behavior. But what we can do is we can just set another trigger rule for this task. So what are those trigger rules? Let's see. So there is this parameter which we can set trigger rule. Yeah, so there are several trigger rules. The default is all success basically, and there are others. But what we are looking for here is one success. So if either of those succeeds, then we will prepare for launch. In any other case, well, we'll be here, I think. So let us try to refresh it and rerun it one more time. Okay. So as we can see, now this task doesn't get automatically skipped, but instead it waits for all upstream tasks to finish in order to produce a result. And yeah, so it seems like we are launching. Okay. Let's see. So what else can we do here? One minor thing about this, so you can actually accept this as a keyword argument, and in order to avoid this line, because we are like expanding this dictionary, and this should be ignored in this case. Yeah. Okay. So it seems like we are done with checking the weather. Let's actually now add some more weight to the launching the rocket task and try to interact with some other system inside it. Let's say we will write to the DB here, and in order to, like, for the sake of simplicity, we'll just use this same DB. Let's create some simple table, which we will write into right here. So create table. Let's report our launch status here. Okay, so this would contain execution timestamp, and for example, what should it be? Execution timestamp. Okay, let's say, let me actually pull up this one. Yeah, timestamp. Okay, so this is timestamp, and let's report also status, which will be varchar of, I don't know, 50. Okay, so let me just run it. Okay. We should have this table right here. Let's see. Oh, wait a minute. Oh, okay, so it got created, but I can't actually see it. That's weird. All right. Can we do this here? Oh, that's weird. Okay. Let's just do this. All right. It exists somewhere, but I can see it here. So maybe reconnect will help me. Okay. That is weird. All right. While I'm trying to think about it, let's work with the Airflow part of it. So we'll be using Postgres operator for that. It is also provided as in a like Airflow distribution. And what we need to set here is we'll need connection. Basically, we'll need the connection ID for that. Let's say Postgres default. I will create it later. And we'll need to get it something to execute. So let's insert some data here into this non-existent launch status table. Execute TS, right? And status. And we'll just insert one simple line here. So we'll need to write something here. And for the status, I think it's really simple. We can just do this. So what do we put here to get execution TS? Well, actually, we can just use Jinja templating, which Airflow provides, and you make use of some macros here. So let's use execution date macro. And yeah. And it seems to be it. Let me just try to figure out what's wrong here. Oh, there it is. Well, haven't noticed it. Okay, so it is empty at the moment, right? Right. And as I mentioned, we'll also need to create a connection. Let's say, what did I put here? Oh, Postgres default. Okay, so this would be a Postgres connection. A host will be localhost, and everything else will be Airflow. Airflow. Save. Okay. As you can see, it is now encrypted as opposed to this connection, for example. and that's because it has password set. Let's see. Let's actually try to run it. So go here, and let's trigger it from the beginning and see. It's a shame they still haven't provided like self-updating view, but I don't know, maybe it's in plans for Airflow 2.0. So we are, what's taking so long? Oh, it's because we sleep 10 seconds. Okay. Okay, and we failed to do this. Great. So what was the problem? Okay, the connection was refused. Actually, as it is in the Docker, it might be not localhost, but Postgres. Let's do this. Yeah, it's likely Postgres before because I remember I've tested it. So okay. Let's rerun this task. Let's not like rerun it by itself, but press clear, which makes no difference for this task because it's at the end of the DAG. Failed again. Okay. Okay. So what happens here is we try to insert this one and it doesn't work because Postgres does not understand this format. Okay, in this case, actually, let's try to use this little macro here, which provides the same thing basically, but in another format, which I think will be more suitable for us. Let's see. No, failed again. Okay. And it's actually the same macro. That is interesting. Let's again take a look at what can we template into here. And in order to do this, we'll need to go find context. And the context in the most like suitable way we can find, I think, here. Let me just do this. So yeah. So basically, yes. Everything we have here. So what could we use from that? Actually, I think we have to use this one because as it says, this is basically no dash version, just plain numbers, right? Yeah, exactly. Exactly. It's really interesting. Yeah, and this is an ISO format, which is not suitable for us, apparently. Okay, let's try to do this. Well, TS no dash. Oh, also, I forgot to refresh last time, so that also might be the reason. Let's actually see. Yeah, this is likely. Is it no dash or just TS? Let me see. So no dash is, no, it's no dash. Okay, never mind. So let's try to rerun it once again. See what we get here. Fail again. Okay, debugging live. Interesting. So maybe what do we want here is this is a dashed version. Oh, okay. Yeah, this might make sense. Let's try it. Let's try it once again, but now I won't forget to refresh the deck. Right. We've seen this before, didn't we? Okay, let's, oh, I think, yeah, what I am forgetting is basically a single quotes here. Right, yes. Okay, let's just try it. Okay, okay, now I feel a little bit stupid, but we got it. So let's go here and see if we actually managed to write anything. Yeah, we did. We have written this execution TS here, and that's great. Okay, so how do we know that this field SQL is templated? And which fields are templated even, because some fields are not. In all operators there is a field, template fields, which says which fields are templated and which are not. So you can see it for like HTTP operator, for example. The endpoint data and headers are templated and the method is not. Sometimes it might make sense to override inherit a class and add more templated fields, but usually everything is templated. Everything which makes sense to be templated is templated in Airflow. Okay. So let's try to add some more notifications in our pipeline. Well, not more, but any identifications will do. So what mechanisms do we have for it? Well, there's a lot of parameters to this one, by the way. So among others, there are on success callback, on failure callback, and I believe there is on retry callback. No? Oh, okay. So that's on the whole DAG. What we're looking here is parameters to the DAG. And if we go to the individual task parameters, and we go to base operator, so here we can find on retry, on failure, and on success. Yeah, on success. Okay. So let's actually do something when well the rocket launches. So for that we'll need to add this here. That would be on success. We should say on success back. And yeah. What all callbacks in Airflow, or at least those three, accept context, but not as arguments, but as a single argument. So that's important. And here, what we can do is we want to actually send a Telegram message. So let's start with a function which actually sends a message to the channel. Some message. So for this, we have this dependency called telebot. And yeah, so we can construct a bot. For this, you'll need a token. And I will be again using it from environment variables, but I'll show you in a bit how can we not do this. So this is Telegram bot key token. And yeah, parse mode. Let's say it would be Markdown, or the default HTTP or HTML, sorry, whatever they have. Nah, doesn't matter. And so the bots have, this bot has convenient method to just send a message. And here we'll put the ID of channel, which I will fill in a second. And the message itself, which is, well, message. So we have this chat created for alerts, and not only, and we have the bot already added there. So let us actually try to notify this channel. The rocket has been launched. And we'll also, to just show what we can do here, we'll just put something like execution date here. Okay. Now let's try to run it. On success, go back. Let's actually remove this and run the whole pipeline once again. End to end. Forgot to refresh. Okay, let's refresh. And see what happens. So main question is, did it refresh? and you can see that it did. And let me just check this chat. Whether do we have anything here? Well, we don't. So let's try that one more time. Let's try that one more time. Let's do this. Okay. So what do we have here? We have nothing. Well, in this case, we'll need to think what we do wrong here. So let's see. We can also see like these logs here. Chat not found. Wow. Let me just check the name of the chat. Airflow workshop. And what did I put here? Oh no. Okay. I see now. Let's restart it one more time. So this was just a typo all along. And we should have, yeah. So it posted a message. Great. And likewise, we can also have on failure callback and on retry callback. So yeah. So what are we missing here? Actually, this is not a very Airflow way of doing things. So first of all, we ideally want to use a connection here, even in callback. And second of all, we would like to actually have it not just as a function, but we can have this logic encapsulated somewhere, and we can just reuse it. So how can we do this? Well, in Airflow, there is a notion of hooks. And hooks are basically there to simplify our work with the like confidential data, passwords, and so on, and maybe simplify some logic to unrelated to like security concerns. So what I want to do actually is to create a hook. We can create a hook anywhere, actually. We can just write it here, but as we also have this directory defined for the Airflow to read Python code from here, we can define it here. So now let's actually just write it here for now in a DAG itself. So that would be Telegram hook. And what do we need here? First of all, we need to extend the base hook. And we need some init here. So now we'll be doing things properly, and we'll actually use connections because they play very well with hooks. For this, let's define connection ID and well, store it here. Let's just say that we'll also need chat ID, but we'll have it none for now. So one important method we want to override is getCon. Yeah, this one. What it does, let me just show you. Why is it needed to be overridden? Well, no docstring. What a shame. Okay, so basically, by convention, this method is used on hooks to get the underlying thing that performs actions. It is very suitable for hooks which are wrappers around around some libraries like Bottle3 or in our case Telebot. So in our case, it will return Telebot instance. And what do we want to do here is we want to use another method from here to retrieve the connection by its ID. It is implemented for us. Yeah. And what we want to do with this connection is we want to extract data from it. So this connection is actually exactly what we see here. So I've already created the Telegram connection, but yeah. So we'll have all these fields accessible from this con instance. So we'll need chat ID, which I have put into login field, which is this one. And we'll also need a token, which I've put to the password field, and it doesn't show in the UI for obvious reasons. And for this, we have get password accessor. We have a property. We should have a property to access. Okay, but let's use the getter for now. And what can we do here is just we can create a bot the similar way we do it here. Put the token here, and we can just return it. Okay, this is the first method, and hooks can hooks are usually have wide variety of methods which simplify working with underlying API or whatever. But there is also another important method, which is run. And yeah, this is usually used for the main action, I would say. Do we have it here? Yeah, we do have it here. We have this parameter named SQL for some reason. In our case, it won't be SQL, it would be a message. And what we want to do is we want to self get con and send message. The same way we did it before. Let's see. Okay. Oh, yeah, and this needs to be to some chat ID. Okay. And as you can see, you can also have like a singleton here to not instantiate it or whatever you prefer, basically. And here we would just use a Telegram hook. We can construct it. Let me just do this. So this is the message, right? And look at this. Yeah, we'll need to provide connection ID, which is Telegram in our case. And we can just use run to send the message. Okay, so let's try it out. Let's restart this, launch the rocket task. And see what happens. Interesting. So what happened here? Basically, we made a mistake somewhere, which is probably related to this. Okay. Let's see. Let's see if we get the correct connection here. So for this, I will print com login. Okay, we use the correct connection. Maybe I have malformed token here. Well, that's like most likely what happens. Okay, if we're going to leak the token, let's do this. I'm sure it can be invalidated. Okay, let's see what happens here. Didn't refresh. Okay, this seems like a correct token actually. What else can go wrong here? That is actually quite interesting. Bad request. Okay, just checking myself here. What am I sending even? Or even, yeah, so it happens here. Let's see. Okay. Did I restart it? Probably yes. Oh, none. Okay. Yeah. That is something you would expect from trying to write as little code as possible. So yeah, we initialize chat ID inside here, and yeah, we also use it here. Wait, no. So it should be initialized actually. Let's try it once again. Did I refresh? Let's see. Okay, it doesn't work. And I'm not really sure why wouldn't it work. Am I sending something like bad? What? Let's do this once again. As you can see, the process of restarting like things in local airflow is very quick, but might be a little bit, it might take a little bit longer in production env, but usually if you have access to like dev env and can edit DAGs right in the directory from where they get parsed, you can expect like this kind of quick debugging without much thinking. Well, it seems like these are good actually, but for some reason we fail to perform this action. Okay. So this is basically the idea of hooks, and yeah, it should be working, but yeah, for some reason it doesn't want to. All right. So what else can we do here? Actually, not much. I believe we've covered all the operators we wanted to implement. And yeah. Let's actually try one more thing. So we won't be sending this message, unfortunately, because of this issue, but we can try showing that files would be picked up from here. So this is Telegram hook. Let's put it here. Let's import this. Yeah. So here we can just import it. There is actually a difference in imports. So something that I probably should have shown earlier, but yeah. So basically you can import inside an operator, inside from, for example, a Python callable, or outside. And what's imported outside is always imported at when at the time of parsing the DAG. This is actually not always desirable. So, for example, this toss a coin function. Suppose we have this choice. Well, it's from standard library, but suppose we have some custom choice, and in the scheduler side and the web server side, there is no such package. It is not installed to like preserve space, and maybe we just don't want to load it here. So we can always put the import right there. In this case, it will be only imported inside the worker it is currently executing, and it will not affect like the DAG parsing time or whatever. It will not require this dependency to be present on scheduler and web server. All right, so the question is, can we use this extra folder? And let me try this. Refresh first. All right. So yeah, what happened here is basically this Telegram hook got picked up from this place, and well, it executes well except for this part. All right. I think that is it for what I have. Let us turn to maybe questions, or Vlad, what do you think?
Yeah. So I guess, yeah, we covered pretty much all the major topics. And yeah, we are running out of time. So as we mentioned, we have this book for one of you guys and yeah, I guess it will go to Andrew. So yeah, we will send you it via the email. And yeah, in terms of any other questions, I guess you can join this Telegram channel and continue discussion there. As for this hook stuff, I guess we can just leave it as a homework for our attendees. So yeah, as a final remark, just want to say thank you for attention. Have a good week, and see you later.